Hear me. You guys hear me out there? All right, well. I'm not worried about you guys hearing me because I can shout. I can tap the microphone and I can hear it through the speakers in the room, so it's kind of weird that it isn't. I would rather they not use C# for the project because I probably won't be able to run their code then. Yeah, sorry, I'm answering questions from the remote students. I have the screen muted in here, so the college students are like, what is he talking about? All right, what am I doing?
I do too.
Good morning, everyone. Are there any questions to begin with? Any other questions to begin with? Katie? Forget to press the button.
I know you changed some of the due dates from what the online it says to other ones. Could you just like, I know for the one that's due on a Sunday, you wanted to change it, but I didn't remember what day.
No, I didn't want to change it. I just wasn't comfortable with saying it's due on the Sunday. So I said, imagine in your head it's due the previous Friday, but in fact, I'm not going to look at it till Monday.
Oh, okay.
I'm just not comfortable telling you work is due on a Sunday night because I'm not going to work Sunday night and neither should you. So that's Praveen's thing, I guess. Other questions? Okay, so I promised to give you guys an introduction to the Java FX system today. And to be perfectly honest, I've been short on time with kind of a family emergency at home, so I haven't actually tried this on the Windows machine yet. So this could prove to be a spectacularly uninformative demonstration that will go down in flames. But I'm going to give it a try, and we'll see how far we get. And if I can't make it work on this computer here in front of us, then I will go for plan B and start talking about the next chapter, and we'll try again on Monday after I have some more time to fiddle with the Windows box. All right? So Java FX is sort of the quasi-modern replacement for the old Java Swing abstract windowing toolkit, which is how I learned to do Java graphical user interface stuff. And it has a somewhat ambiguous future because of the big changes that are being announced by Oracle for Java 11. But at the moment, it looks like it's going to work for anybody who's got Java 8, 9, or 10 installed on their machines. The library itself doesn't change all that rapidly between those various builds. So I think it's a reasonably good choice for us to try to do the graphical user interface for our project. That said, doing graphical user interface programming does require understanding a lot of extra class libraries because graphics are somewhat complicated. And these libraries offer you the capabilities to do all different kinds of things, from making simple two-dimensional games to playing video and audio in a particular window, to creating simple web forms of the kind that would be appropriate for this application. So there's a lot of possibility, and that's why the libraries are fairly complicated. But there's a really nice tutorial here linked at the bottom. So I'm going to try to follow the first few steps of that tutorial and see if that works out. So let's see. I need to share my screen. So I'm starting out on the bottom of the assignment specification for the final project, and I'm going for this first one here, the Java FX tutorial. All right, lots of background reading here, and notice that this tutorial covers all kinds of stuff that's totally not applicable for our final project. 2D and 3D transformations, transitions and animations, incorporating media. None of that's relevant for what we're trying to do, right? So skip those bits, focus on the parts that are for basic user interface stuff, and it's not too much to have to read through. But there's some great documentation here. I've been reading through it this week, and lots of great examples. So we're going to start with trying to actually do one of the examples. So I'm going to try to do the Hello World Java FX style because it's tradition that we always start with Hello World. All right. So here's the code. Now they work through most of this using NetBeans, but I'm going to try to do it through Eclipse because that's what's installed on all these computers and all the Windows and Linux computers that are in the other laboratories, 310 and 101. So we're going to see if that works on one of these native machines here. So probably for the first time this semester, I'm going to crank up Eclipse. Feel free to follow along, those of you sitting in front of a Windows computer here in the room, because you should have exactly the same version of Eclipse sitting in front of you. How many of you have already installed Eclipse on your own machines? Okay, so the vast majority of you. And so you've been using it to some extent, a lot of you? Okay, good. So I don't have to like explain Eclipse and its inner workings, because I don't really want to explain that stuff. Come on. So if this next bit works, I know for a fact that we're going to have to wait for it to download the thing. So I'll probably have to like come up with some jokes. So under the Help menu, once Eclipse comes up, if you haven't worked with Java FX before, there should be an Install New Software chunk down here. So Eclipse isn't really just a particular piece of software as much as it is a whole ecosystem of software. Oh, look at that. Right there. EFX Eclipse IDE update site. Yes, give me that. That's exactly the thing I was going to look for. Select them all. Why not? Put them all down. Why can I not click next or finished? Okay, exciting. Expecting these buttons to come live here. Maybe not. All right. Let's go back and try available sites. So the Eclipse plugin for Java FX is called E open parenthesis FX close parenthesis Eclipse. Get what they did there, right? Isn't that clever? Come on, search. Search. Come on. I like how that seems to have hung my Eclipse window. Yeah, the mouse works over here, but when I go over here into the Eclipse window, my mouse goes away. Yes, as I suspect. Oh, wait, unable to read. What? And because the mouse is not back, I cannot click on the OK button. All right, how do we force quit stuff in Windows these days? Control Alt Delete. Does that give me the task manager? Yes, not responding. Add Eclipse. All right, let's try it again. Not that I'm quite sure which wrong turn I took there, but you know, computer science is about being persistent. Face of an inscrutable machine that you know is usually working again. Oh, software. Software sites. Oh, hey. Anybody following along with me? Are you getting the same problem? Kai, what do you got? Oh. Yeah, see, this is a much longer list than I had before. Where is oxygen? No. Actually, no. Because this is neon, right? Oxygen is the next version up. I think so. Wait. Do you have a different version of Eclipse on all your computers? Really? So
I don't know if this helps at all, but I went to, instead of install new software or whatever, I went to the marketplace, which is like the one right below that in the help thing, and I was able to find something that looked like FX, and I'm downloading it, so.
Okay, I will try that next. Thank you, Joseph. All right, so in the meantime here, this thing seems to be stuck realizing it can't contact any of the remote sites that it wants to talk to, which is awesome. Kill. All right. Help Eclipse Marketplace. Okay, that sounds fancy. That was not an option on the Linux version of Eclipse I was trying this with yesterday. Okay, that one. Can't scroll down, and when I click on this, it takes me back here. What's So if I'm more specific, will I get the one I want? Come on, Eclipse, work with me here. Nope. I just can't download it on this machine, but you can on yours, right? Huh. Well, let's see. I didn't bring a laptop with me. Well, super fun. All right, so you guys have Eclipse working with a bunch of you, right? Is everyone within view of someone that can see a working Eclipse window that has the Java FX extension installed, more or less? Raise your hand if you've got one to share. All right, those of you who don't have one, look around you, find somebody who's nearby, and move about the room if you need to. We'll try this remotely, where I can't actually see what you're doing, but I'll guide you through the steps. All right, so ideally, if you've got this thing installed under Eclipse, when you go to create a new project, so go into the File menu, go to New Project, instead of selecting Java Project like you usually do, go down to Other. And under the Other section, you should find a Java FX section. And under there, there's Java FX Project or Java FX Application. It seems to depend upon which version you actually start with. All right? Does that sound right? This is what I did last night when I was trying this on my Linux box. No. Is there another choice? Java FX Project, right? Is that what it's called under Eclipse? Okay. Try that out. It's going to ask you for a project name. Try Hello World or Hello FX World, right? It doesn't really matter exactly what you call the name. Just remember what it is later on. Ms. Homiampur, do you have any suggestions for how to get it to install with Neon here on this machine that I'm on, if it's working for you guys out at your school? All right. In the meantime, so brand new Java FX project, right? It's going to build a bunch of stuff for you, so you should see a couple of boxes underneath there on the left in the project management window. So you probably need to click on the project itself to get the drop downs underneath that, right? And then what do you have? Is there a source directory underneath there? Yeah, so click on the source directory, right? And click underneath that, what do you see? Application. So you want the application package. Anything inside there yet? Ah, there we go, main.java. All right, so open up main.java. It should just be a stub probably, right? So there's just like, there's what? Right, so standard main program stub and nothing, no real code though, right? Does it have a package declaration up at the top? Okay, so that's the package that we're in within this project, right? Does it have any includes, import statements? Not yet. Okay, good. So that's where we ought to be in order to start this next demo here. All right. So open up that class there, and we're going to copy paste in this stuff from the site. Now, did you follow how I got here? Are you able to get to this example code? So let me back up a little bit. I started over here, clicked on JavaFX tutorial. I clicked on get started with FX, and I clicked on Hello World JavaFX style. We've got a bunch of code down here. They're using a package Hello World, so their example is using this NetBeans system, so it's not going to totally be set up the way ours is. But we should be able to copy paste all these import statements on down. Grab that whole method, the start method, and copy paste that in to your little main stub there. So you'll have a different package declaration up at the top. Keep your main program, but add in this call to launch of args. Right, so that's how it starts running to begin with. Right, so you should have one main method that has this line of code. You should have this whole thing here, a start method that you copy in off of the demo website. I don't know why this line of code is not properly indented. There's nothing special about this. This should be indented with everything else. So feel free to fix that. All right. So what does this code do? So we're having the main program call launch, which clearly must be a method that we are inheriting from this JavaFX application class. Because we've got an import statement here up at the top, we can just say that Hello World extends application, and we're good to go. Colin, question?
So when I opened my code, I actually had 3 import statements and a start method already written.
No kidding. Yours, you started with something different than some of the other people?
Yeah.
Different version of Eclipse, maybe? Yeah, so I think we're seeing different variations on what the default starting behavior is in different versions of Eclipse.
Should I just replace that start method with the one in this code?
Well, what's in your start method? Is it something useful, or is it just an empty stub?
There's a try catch block, border pane root equals new border pane, and then a scene variable.
Oh, so maybe it is starting with a real basic demo.
Get style sheets. And
feel free to try just running that first and see if that pops up with like a naked window that's like the start of a basic demo program. All right, if it's already giving you like some stub code, give that a try. That might be a good starting point. Once that works, then yeah, I would totally replace that existing template start method with this Hello World start method and see where that gets us. All right, so we're inheriting a whole bunch of functions from this parent class application, right? So the JavaFX library knows all kinds of things about how to make an application, and one of those methods is the launch method, right? And we're just passing on whatever arguments get passed to the main program, but that's there. We're overriding the start method that is inherited from the application parent class. So somewhere in the guts of the system, it must call this start method. So this looks a lot like when we when we were working with creating a basic thread, right? We made our thread class extend the Java thread class, and then we overrode the run method, even though that's not the method that we called from the main program, right? But we knew that that was the method that was going to get executed when the thread was launched. Same kind of thing here. So there's not a direct connection between this call to launch here in the main program and this start method that we can see, but it's in the background. It's what this application class that we're inheriting from knows how to do. So it's allocating a new button object. It knows about buttons, and you can see that that class was imported here from the JavaFX library. It's telling the button what it's going to have in it, and it's setting an action. And what is this here? Yes, true. Java syntax-wise, what is this where I see I'm calling a constructor and I'm following it with an open curly brace, and then there's a bunch of stuff inside the curly braces? Katie? No. It is called something funky, but I don't remember using the word ghost for it. I've done this twice now, this construction, in the past couple weeks. Do you remember the technical term for what this is? This is an anonymous inner class that we're defining, right? Because look what's inside of here. Another method declaration. I'm inside of defining the method start in the class hello world, and all of a sudden here's public void handle. Here's a whole nother method that I'm just kind of throwing in here, right? This whole construction, the curly braces inside here, are an anonymous inner class that inherits from event handler of action event type, and I'm overriding the handle method to do this special thing. All right? I just don't want you guys to get lost in the syntax. I would not expect you to know, if I was typing this code from scratch, oh yeah, at this point I need to create an anonymous inner class and override the handle method in order to print out something when the buttons get pressed. But seeing this example, do you see what you need to do to modify what the button's going to do when you press it? Yeah. All right? That's where we want to be, is at the point of being able to know how to modify these examples that they're giving us. Right? There's a stack pane, which is a particular kind of pane where stuff is going to be stacked top to bottom. We need to, so these JavaFX classes are organized into a tree, basically. So you've got a root node that sort of owns all the stuff in the scene, and we are adding this button as one of the children, right? So we have the stack pane root, which is the new stack pane, and we say, get the list of its children and add to that list this brand new button that we've allocated, right? So we're adding this button object to the tree that represents the scene, and the pane, rather. This scene, basically, we're giving it the size here, the title. We set it up to register and tell it to show, and that ought to do the trick. All right, so when you copy this code over, replace either add a start method, depending upon which kind of template you started with, or replace the start method it gave you. Click build and run. Do you get a window that pops up? Yes, I'm seeing thumbs up from several people. Okay, and when you click the button, what happens? It prints hello world. Okay, awesome. So even though I cannot run the demo on this computer, you can see how this starts, yeah? All right, good deal. Any questions that I can answer, not having a working example in front of me? Katie? So how do you organize multiple pages in the application? The library is flexible enough that there's a variety of ways that you could do that, because you can either modify the existing scene, or you could have several scenes that you switch between and then tell them to show based on certain actions. So there's not one way to do that, but one of the tutorials actually does something like that. not one of these basic ones, but one of the more advanced examples. So if you look through the rest of these, I would skip the animated shapes and visual effects one. Many of you will not have a lot of time for user interface design, but you can see how to do basic forms and to use tables and that sort of thing. So where is the... Exactly where that one is, Katie. I have to get back to you on where. Well, definitely take a look through the tutorials. I know I saw one in there that sort of changed the mode of the window and did a second layout, and that's pretty much what you're talking about. All right, so they're buried in there. The second major piece that I want to point out is this JavaFX Scene Builder tool. So how many of you have already found your way to this? Okay, awesome. Would you care to comment on what it does?
So what it does, it's instead of having to write the whole GUI from code, you literally drag and drop components to make I guess the image you want to display, the scene. And all you have, and from there you have this. You can link your GUI to your code by using what's called the controller class, and you can call different methods to like work with different components. For example, if you have a button, you have a method calling detecting what the action of the button will do, and it will link it to your code that will essentially display or do whatever you want it to do.
Summary. So you've got two fundamental pathways you can follow for using this library to build software. You can do like this example with the hello world, where we literally typed out the code that said, create a new button, add it to the scene, show the scene, right? Or you can use this tool where you can draw out the interface graphically, select, I want a button here, I want check boxes here, I want a text box here, and then connect the code to that after the fact, which usually when we're building a graphical user interface, that's the preferred method, right? So ever since Interface Builder appeared on the Next Step machines in the mid-1990s, that's been the preferred way for building complex interfaces, right? Xcode does this. Lots of IDEs will allow you to start with, I want to lay out the objects first, and then have all the stubs for the code be automatically generated and fill them in as I go. So that's a really good way to do this. Scene Builder, JavaFX Scene Builder, is the equivalent tool for doing that with this library. It's a separate piece of software. Go find that and use it. It will make it a lot simpler.
The only thing I did find a problem with is that as of now, the current version of Scene Builder that they have only works with JDK 8.
Okay.
I had to use it in NetBeans because somehow Eclipse just wasn't working.
Oh, really? Okay, so got to go with NetBeans? Go with NetBeans, I guess. I don't know. I'm probably still going to use Emacs. So, but yeah, there are versions of that Scene Builder tool that should work on most platforms, but you may have to make sure you have the correct version of Java installed. So what's on all these machines? Java 10, I think, right? So I think we have reverse compatible versions of the older Java runtimes. So it should work on all these lab machines, for example. I'm not going to even bother trying it out on this one up here because this one's a different build, obviously. Then it should work on Linux and OS 10 as well. Right? So use your preferred environment. The whole purpose of this is no matter which platform you build this graphical user interface on, it should work, it should run properly on any of the platforms. That is the promise of using the Java virtual machine as the underlying tool for this, is that your GUI programs will actually port properly between Windows and OS 10 and Unix, which is not the case for lots of other graphical user interface programs that we might do in, say, like C++, for example. That's a nightmare when it's time to port to another platform because all the windowing functions and libraries are different. Java actually provides that extra level of abstraction to try to help us out with that. Right? Colin?
So I'm assuming that we'll probably have to use some CSS to like change color for a lot of our GUI stuff. Do you know if the Java FX Scene Builder deals with any of that, or is that stuff we'll have to code in ourselves?
Some of it, right, Francisco?
Yeah, so when you, there's some options that aren't directly available in the properties tab of the scene builder. So you actually have to open like the FXML file or the CSS file and code it in.
And that includes like basic color stuff and font stuff and size stuff like
Yeah,
that, right?
yeah.
So
Otherwise, I mean, you can, the only thing it really lets you change is the component background color. But for that, you also need to have the actual code to the color. You don't get selected.
oh, you need the
The, like,
Color code.
yeah,
color code.
yeah.
Which you can Google.
The color codes, that should not be a big barrier, right? If we know how to generate a color code, basically just a hexadecimal version of the red, green, and blue values, right? Or search Google for the color code, right? It's the same as the HTML color codes, right? That's totally what it is. So if you've ever, lots of resources available for that. Or simply figure out the corresponding red, green, and blue values and do the conversion and put it into hexadecimal, and that'll be it, right? Yeah, I know that's so old school. All right, fine. Only I'm going to do it that way, but the rest of you could if you wanted to, if you put your minds to it. All right, so worst demo of graphical user interface ever, but is everyone near enough to a working version of this thing to have some idea of where to get started on building their graphical user interface part? All right, so I will work on this particular machine hopefully this afternoon and see if I can actually demonstrate the thing that I'm telling you is so easy to use actually on this screen. All that prize we're going to get for that. Ooh, suggestions. When you go to the install new software window, there will be a bar at the top of the label work with that chooses the repository that you are searching for. All right, thanks, guys. I will try that, but probably after class is over so that we can actually cover something useful. That's very helpful. Thank you. Okay, so what are we going to do instead today? How about start the next chapter? You're all very excited by that prospect. The map abstract data type. So what's special about the map relative to all of the other collection classes that we've seen so far? The big thing that differentiates it is that we are mapping from key to value. Right? So all the previous collection interfaces that we've talked about have been solely about storing the values. And then sometimes we have indexes for them, but we're always trying to find a target value or store a target value or remove a target value. And we don't really care so much about the underlying representation for where it is stored. A map, you always have things in pairs, right? So we could have a map that maps last names to student IDs, right? So the type of the key is going to be string, and the type of the value that I'm after is going to be integer. But we have this one-to-one mapping where every key value is going to give me a unique student ID, right? So that's an example of the map interface. What is this called in Python? A dictionary, right? So for those of you who started in Python last year, only now, 2 semesters later, halfway through the data structures textbook, do we get to one of the most basic data structures that is built into Python that you use all the time, the dictionary, right? So for Java, this is like a pretty fancy data structure. But in Python, it's just a fundamental tool that you use all the time for even very simple programs, right? So I think as Python programmers, I don't need to explain to many of you what you would use a map for, right? The question is, how do we efficiently implement a map in Java, right? So the map interface is pretty straightforward. I'm not going to, yeah, might as well. Yeah, right. Didn't open my Dr. Java window up front. All right, so public interface, app interface. So unlike all of our previous generic types where we just put there was a type T for our collection class, this is going to be generic over two different types because we need to have a key type and a value type. All right, so between the angle brackets, we put two different type variables, and we separate them by a comma. All right, that's not going to make anybody terribly confused, right? And because we now know about iterable, we want to make sure that we extend that interface so that we can use iterations for stuff. And that is going to be all right, so there's a lot going on in here. Do you understand what this bit is saying? So I want to make this this interface extend the iterable interface, but the iterable interface only takes one parameterized type, right? I can iterate one kind of thing. I can iterate strings. I can iterate integers. But our map entries are going to have two things, a key and a value. So we're going to introduce this other helper class, map entry, that binds them together. So a map entry will store a key and a value. And that makes it one object, one class, that then can be the parameterized type for iterable. Right? Starting to get kind of fancy with the generic types here, well beyond what we've seen before. But hopefully not so much that you can't follow. All right, so what are the methods that we have to have inside of the map interface? We need to be able to put things in the map. So the method will be called put. It'll take a key, K. Yeah, this is getting kind of crazy with the uppers and lower cases. Hopefully the pattern will make it obvious which thing is which, right? And a value, V. And the put method is going to return value V that used to be in there, if there was something there. So it's a replacement. If any entry in this map with key K already exists, then the value associated with that entry is replaced by the new value V, and the original value is returned. Otherwise, it adds a new key value pair to the map and returns null. Right? That's the shape of it. We need to be able to look stuff up, obviously. That's going to return a value. We'll call it get. And for get, all we need is to provide the key K. Right, so I have the key, and it gives me back the value that that key maps to. Okay. Of course, we need to be able to remove stuff. We want to know if we can find a thing in there, so we'll have a contains. And of course, the usual, we want to know if our map is empty. We want to know if our map is full. And it's probably also helpful to know how big the map is at some point. All right? We need to have a map entry. I've already named that class. We've got to have it, right? Public class map entry. Have a key value here. What's going to be in here? Well, obviously, we need to actually have a key, protected K, key. Value, not so surprising. A constructor for binding the two together. Okay. Never guess what the implementation of this simple constructor is key equals k. No surprises there, presumably. We need to have getters and setters. We need to be able to get the key. In there. That got me a funny color. I wonder what that is. All right, so far so good. And then your textbook actually does a override of the toString method, which never hurts us when we want to print stuff out. Public string, toString. Let's return. Print them out on 2 lines with, let's see, do I have enough space? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The colons will line up, so it'll print out nicely whenever I want to print one of these values out. All right, make sense? So those are the basic ingredients that go into this. So how should we implement this map collection class? Now, taken the time over the past 4 chapters to carefully implement different array-based and linked list-based variants of all these different collection data structures. How should we implement the map? I'm not looking for the one true answer here. This is like a discussion, hopefully. Liam? Yeah, so we could make an implementation based upon one of the collections that we've already done, right? We could build a list where each node in the list is a map entry, right? Would this work? Yeah, totally. We can build this. So immediately the question should be, what are going to be the trade-offs for doing it that way? Right? How efficient is it going to be for us to perform common operations if we use a straight linked list approach where each linked list node, its payload, its data field, is one of these map entries? So what are the things that we're going to want to do? We're going to want to be able to put new items in. Okay, so let's say I've got one of these linked list-based implementations of my map. And so I've got a bunch of key value pairs already in there. And I want to insert a new key value pair. I want to call this put method. What's the big O going to be for my put method if I use a linked list-based implementation of this structure? Think for a moment. Turn to somebody nearby and share your answer. Come on. Oh, I'm sorry. Did you not get the question? No? Yeah, I will repeat the question now that you know that you have to pay attention. Let us assume that we're going to implement this put operation on a linked list-based implementation of our map. So every node in the list has a map entry that has a key and a value. I've already got an existing map with a bunch of keys and values in it, and I want to put a brand new key value pair in. What's the big O going to be for me to do that? Right? Now discuss amongst yourselves for 30 seconds, now that we're on the same page of the question. All right, pairs, find another pair near you and share your answer. If you do not agree on the answer, take a few seconds to try to convince the other group that your answer is correct, or be convinced by the other group that their answer is correct. All right, is there a team that would like to share their consensus answer to my question? Alex, go ahead.
Linear?
Why?
Because to go through the linked list to add something would have to walk its way through the list. And so it has to go through every node that's currently in your list before it adds it.
Why can't I just insert it at the front? Big O of 1, constant time, right? I can insert something in the front. Why can't I do that?
Because it's checking against the other keys to make sure that it's not already there before it adds it.
Because I can only have one value mapped to a particular key. So when I call put to add a new value in, I need to check, first of all, is there already a map entry that has this key? And if there is, I'm replacing the value. So I can't do this without checking every node in my linked list, right? So linear time for put. Big O for get. Going to be the same, right? Given a key value, I'm going to have to search the whole list to figure out is my key there or not. Contains, same thing. Remove, same thing. Empty, full, and size, those are trivial. But all the important operations, I have at least linear time if I do a linked list implementation. So, achievable? Yes, absolutely. Is it going to be very efficient? No, it's not going to be a super efficient implementation. All right, so if we don't do a linked list-based implementation, what's our next choice? Array! Yes, I thought you were cheering for a moment there. Right, so that's been the trade-off all through the semester, is like we're either going to use an underlying array or we're going to use an underlying link structure. Okay, so an array, and how are we going to organize the array? Sorted or unsorted? Good guess. Let me be more explicit in my question. So for the linked list, the position of the map entry is basically only determined by where it falls in the list. But for an array, every item in the array exists at a specific index, right? And for most of the previous collection classes we have talked about, the relationship between that index and the thing that we're looking for has been how we get the efficiency improvements for finding stuff, right? So how should we organize our array? What if I give you a new key and value pair, how will you determine what index you should put that into in the array? Because if we just, treat it like a bunch of empty slots and we don't care about what anything is, it's just going to be a static-sized version of the linked list where we have to search all the way through to find it. Every time we want to do put or get or remove or contains, we're going to have to scan the whole array. We'll have gained no efficiency over the linked implementation. Agreed? So how do we organize our entries by key so that the array actually gives us some kind of benefit?
Well, if you sort the keys, like let's say alphabetical, and then you do a binary search on the array.
Yeah, sure. So some key values are going to have a natural ordering, right? If my key values are strings, then I can alphabetize them, right? Or sort them alphanumerically. If my key values are numbers, even more awesome, right? I can just sort the numbers into value order. And if I know that up front about my keys, then I might be able to implement certain kinds of maps where I could do binary search, for example, right? Our phone book search. Look in the middle. Is my key greater than or less than the one that I see here? And then we're going to start getting some of those speed improvements, right? Yes, that is totally a doable way of implementing the map. It's going to take some work. It depends knowing some stuff about our keys. and it's going to be more efficient than the linked implementation. Alex, what are you going to say?
I was gonna say, could you use, like, in that situation, like, try to make like a binary search tree so you could have like the benefits of the linked list where you can keep adding indefinitely, but you can also have a quicker search?
Yeah, absolutely. We could use a binary search tree where each one of our payloads in our node was, again, a map entry that had both a key and a value. And we could sort our binary search tree based upon the key values that were in each map entry, right? And so then we would get those great speed improvements, log n for searching and for finding and for replacing. That would also work, right? We could totally reuse everything we learned about binary search trees. That would give us log n. That's pretty good. Usually can't beat log n for data structures, right? Who's read the second half of this chapter? Y'all just playing along with me, or you don't know the answer that I'm actually fishing for because you didn't read the second half of the chapter that we had the reading quiz for on Monday? It's the second one. All right, so I think I'm out of time, right? Yeah, way out of time. So on Monday, we will look at a way that we can implement this map in, get this, constant time efficiency for most of the key operations most of the time. And the trick here is a magical computer science concept called hashing. All right, so that's our topic for Monday, in addition to seeing if I can get our JavaFX demo to work. All right, have a great weekend. Oh, wait, I forgot my code. Where did it go? No, I made the code. I swear I did. Oh, phooey. All right, I lost the QR code too. Sorry about that. It's not worth your time to wait around for it. Have a great weekend.